Okay, today is 5.5. We're doing a lesson on regression. It sounds like if you regress, that sounds like you're going backwards, like you're getting worse. Doesn't that sound like that for the English language? Okay, but for math, when you're doing a regression equation, what you're doing is trying to take data that might look like this. Would you agree that the general trend is up? Okay, but exactly what equation should we write? You guys know how to do it. If I give you this point and this point, you could write a line through those 2 points. Know what I mean? We've done that a whole bunch of times. In fact, that's on this test, is I give you these 2 points, you got to make me a line. But what if I give you a gazillion points and you got to make a line? You can't make a line that goes through all these points. So what the calculator will do for us is called a linear regression. Linear meaning straight line. You guys are in honors pre-calc, so you have to be able to not only do a straight line, eventually you have to do data that's quadratic. And just so you can picture that, like, can you picture that this red data is kind of quadratic? It's moving in a curve like that, okay? But for right now, we'll just use this blue data, which is linear. And you can't just take these 2 points, because the calculator will do this really fancy calculation where it will run a line through there and then figure out how far off it is for every single point. Notice, it doesn't even go through one of my points, but it figures out how far off it was and minimizes that distance so that it is as close to as a perfect as it can be with the least amount of error. Okay, but there's error on every single point, but it's still a straight line that we can then use to make predictions about, like, where should the dot be if we go a little further over, like over here, the dot should be about there because the line can tell us. All right, so you'll see more about how to use it in a moment, but that's what a regression equation is for. If it's all done, you'll have something like y equals 3x plus 7 or something like that. That would be a super simple one, usually with real world data. These are big, long decimals, but it's got a slope, it's got a y-intercept. All right, now let's actually do one. I took some data last hour on people's height versus their pointer finger. I'm just going to write finger, but it was their pointer finger length. And here's the data I've got so far. A 68-inch kid had a 2.4-inch finger. A 75-inch kid had a 3.1-inch finger. A 71-inch kid had a 3.0-inch finger. Now, is a really big, tall person likely to have bigger fingers? Is it a perfect correlation? No. Donald Trump has been, for example, ripped for having small hands. He does. His hands are kind of on the small side. Just if you look at a picture of him and you look at his hands, it's like, oh, those are kind of actually a little bit small. That's because he, like everybody, has just things that are unique about him. So you might have especially big or especially small hands compared to your size, but in general, if Shaquille O'Neal, who's massive, tall, and wide, has hands the size of a little baby, it would be absolutely, whoa, that doesn't make any sense. There should be a general correlation. Bigger people have bigger hands. So I want to get some more data points in here, and I'm going to pause for a second while we write down a few data points for height versus finger length. Okay, so I'm updating the video here. We are noting that there are some weird things where this person was 66 inches compared to this person was 68, but yet they had a longer finger. 2.6 versus 2.4. That is kind of counterintuitive, but it was real data. The computer, the calculator, will use that and give us the best line it can, the best line of fit for these that it can. All right, so right now, if you haven't already, get these typed into L1, get these typed into L2, and then I'll tell you what to do next. I'll pause for a second while you do that and record. Okay, so I'm back and I got all my data in on L1 and L2. Raise your hand if you're ready, because you got all your data in on L1 and L2. Okay, good. I'm seeing pretty much everybody. Okay, now, next step, pausing for a second. All right, okay, so now I'm going to go to Stat. And where do you think I would calculate a linear regression? Under Calc. Arrow over to Calculate. Now, Which of these looks like a linear regression to you? Number 4, linreg, as opposed to quadreg, which would be a quadratic data regression, or cubic reg, which is cubic data. This one was going to be a straight line. So it's linear regression. Okay, so hit the number 4, or I'm going to arrow down to 4. Enter. Now, this is where our calculators will be different. Some of you have the same thing I have up on the screen, and some of you your calculator just says linreg, and there's nothing else. It just says linreg. How many of you have the kind that just says linreg? All right, so you 3, listen close. 4 maybe. If yours just says linreg, you have to type in after it L1, comma, L2, those are the keys above the 1 key and the 2 key, comma, Y1. The comma is right above the numbers. L1, comma, L2, comma, Y1. Now, if you've got the same thing as me, it probably already says L1 and L2. Do you get what I'm saying? And then it has this one, which we can leave blank, the freak list. We don't need to list any freaks today. Moving down, I know, it's the frequency of the list. We got to do store, and this is the part where we would store, and I know some of you are asking, where is Y1? Let me show you right now. Here's where Y1 is. You're going to go under vars. I'm going to leave it highlighted in red for a minute on my screen. It's right here by the clear button, vars. What kind of var do you think we want? A Y var, so arrow over to Y vars. Now, which of these do you think it is? Do you even know what parametric and polar are yet? No, you will by the end of the year, but you don't yet. So, of course, we're not going to use those. We're going to use just function. And then, do you see Y1? Hit enter. That goes again under vars, Y vars, function. And this is, again, your first call for help is right across the aisle from you. Then we got to go down to calculate and hit enter. Now, this is where everybody should come out the same. If it's not, one person did something wrong, and we have to figure it out. Mine says 0.049 is the A, and the B is negative 0.65, blah, blah, blah. Would you please check yours with the person across from you? I know you might have looked at the screen. Check across from you. Make sure theirs is not messed up. I'm going to pause while we do that. So, now we've got our equation. Now, what is it? Well, it stored it for us in the normal form. It's y equals, I'm going to round here, 0.049x plus negative 0.65. But if I go to the y equals key, everybody do that, please. It's got the whole decimal in there. That makes the equation much more accurate. That's why we don't want you to just round it off and use it. We want you to use this accurate equation right there. Because if you round to 0.049, it is so much less accurate than 0.049682875, blah, blah, blah. All right, and you'd have to arrow over to see the whole thing, but you just have to trust that they have put in the exact equation for you. All right, so now how do you actually use this thing? What are you going to do with it? All right, so let's go back to the real world data that we have. If I gave you a height of 74 inches, you should be able to figure out how long their finger should be. Use the table. Everybody go to table. And this equation is now in the table. Because we put it in the y1 and the y2 and on the y equals screen, it's here in my table. So now, I got to figure out if I follow this equation out to 74, and by the way, if yours starts at 1, you might want to do your table settings. Let me just show you that, because a lot of people's table settings are off. Go to table settings. Oops, I hit the wrong thing, sorry. Table settings. I should have it start at like 73 or something. So I'm going to move this out of the way. Have your table start at 73. That way, when... Oh, I hit graph by accident. Come on, calculator. Table for me. There we go. Okay. So there we go. Looks to me like a 74-inch person should have the finger that's about 3.02. Now that just is not perfect, but they have tables just like this in the morgue. Why? Good thought, but that's not what I was going for. Yes? So you can identify the person, yes, but what would the situation be where you're like, I don't know whose hand this is? I mean, Yes. If you just found a hand. It sounds terrible, but it does happen. Every now and then, a farmer is out in their field and they'll see like, oh my gosh, that looks like bones. And then if they're smart about it, they don't just dig it up and keep it in their basement or something creepy. They call the cops and say, I think there's bones in my backyard here, unless they're sure it's like a deer carcass or whatever. But if they think it might be human, you call up the cops. Cops come out. They do a very thorough, like they very careful about how they get that. But let's say it's just a hand. Do you get how you could measure the finger and then tell how tall the person was? And then you could like rule some things out, like, again, these are terrible situations, but it does happen all the time where there's a mystery, like a missing person. And you know the missing person was 5'10". What if you find out the finger belongs to a 5'10" person? Then you're like, ooh, that's probably the missing person. See what I'm saying? So let's imagine for a moment that we just found the finger in this case. And the finger was 2.1 inches long. Could you use this equation, probably the table, to figure out for me how tall the person probably was if their finger is 2.1 inches long? So I'm going to go into my table and just basically arrow up until I find. I'll pause for a second. Okay, for those of you at home that might be having trouble arrowing up on your chart, one of the smart kids in here told me if I moved over to the X column and went up, it would allow me to go up. Because when I was over here, it just wanted to jump up into the header. But if I go over to the X column, and I'm in the X column, I can arrow up. Okay, and I want to go till I find 2.1. And so there's 2.17. 2.12 is pretty close to 2.1. So 56-inch person. Yes? Who said 2.07? I don't understand where that came from. Oh, so you're saying the next one's even closer? That's about 2.08. Would you agree with the rounding there? Okay. And then the next one's about 2.13. And so I agree. It's right in between 55 and 56. In fact, if you really, really had to get accurate, do you get we really got to get in between these? So then we got to go up not by ones. How do I get my chart to change so it isn't counting by ones anymore and counting instead by tenths? Table settings, yes. Go to table settings, change this to 0.1. We're not going to get this intense on you, but if you had to, now that's how you'd change it. We're going back to the table, and now it's counting by 0.1s. And if I really, really want to get close, 2.10, there we go, is, we once again have to round, don't we? It's really, really close to that one. 55 point. Let me check and see which is closer. It's off by 7. It's off by 1,400 or thousandths. I'm pretty sure that's it. 55.6 appears to be the one, if you count by 0.1s. Oh, you're right. I was looking at. You're right. Thank you. Hold on. Yeah, but this one's off only by 5 10,000ths if you really want to play that game. 55.5, there we go. I think that's the one I'm settling on. Okay, so I've gone beyond what I needed to teach you this stuff. I tried to make it real world so you could see how you could, instead of just here's a bunch of numbers, stick them in, try to show you how you could use them. Now, your homework for tonight is 2 problems like this. So everybody try to find the homework and where it starts. I'll pause for a second. Okay, so here they are. It's 5.5.1 exercises. And all I want you to do is 2 problems. This one and this one. Now you will see that sometimes the teacher that makes the key likes to put in, instead of 1950, they'll just put in 50. And they'll just put in 60 and 70 and 80 and 90 and, oh, what would you do? 100, I guess. My point is, you can do that, but personally, I think it just stays more accurate to understand if you leave the original numbers in there. Yes, you then have to adjust your table settings because X is now going to be 1,950 for 1950. Get what I'm saying? If you do this, now that's the downside, is you have to adjust your table settings to start at 1950. Otherwise, your table, you'll have to arrow down like 5,000 times. Okay, so we're doing these 2 problems. This one and this one. And again, I would just type in the exact numbers that you're given, like 1950. Instead of changing it to 50, leave it as 1950. In my opinion, it's easier. The only problem is you got to go to your table settings. I'm going to show you that quick. If I had 1950s in here, I go to table set, which is above, second here, right there, and then make my table settings start in 1950 instead of at like 50. And then you probably want to count by ones then, not point ones. All right. So that's all I got for you for today.